Alright guys, so today I'm going to show you how to pin and weld a CRV diff and why we have to do this in Honda applications if you want to do it for performance. So I'll be honest with you, I already did it. I'm filming this intro video afterwards because I forgot to do it before and video looked a little funky. So here is suddenly a painted diff, which is about to get dirty once I show you the actual process. But CRV diff, these are known as the dual pump diff in the Honda world, and what that means is, I'll show you when I break it open, there's a dual pump system in there with a drum with a clutch basket, and when the pump sees slippage because the drive shaft is spinning but the rear wheels are not, that means the front wheels are spinning. So then it applies power to the rear by pressurizing and, you know, applying those clutches. So that's how in a CRV or newer Hondas the transfer case slippage is done between the front and rear, because unlike other cars that have like a transfer case in the middle of the car that does all the work after the trans, in a Honda like this, it's like, think of it as like a front wheel drive trans, but then they just added on a little transfer case onto the side, so then it's always, there's no slippage done at the transfer case, it's just one-to-one. So there's no slippage done anywhere else down the line if you were to do a, say, a solid, a normal diff and a solid drive shaft. So when you go to turn, it'll be like a truck and four-wheel drive where the front and rear turn at different rates, so it binds and pops and it's not good. You could keep a dual pump from the factory if you wanted to do this kind of swap but didn't care much for maximum like drag strip performance and stuff like that. The dual pump system works okay, but again, it needs to detect front slip before it starts applying power to the rear. So you'll be spinning your front wheels before the rear start to hook up, which is still better than just normal front wheel drive. But for what I want to do with this car, I want it to be capable of drag racing, so I want it to hook up from a dig pretty well. So this diff is going to be not going to have a dual pump anymore. It's not going to have the clutch backs. It's just going to be like a normal differential. And then I will be running a two-piece drive shaft with a Freelander viscous coupler in the middle. So it's going to be more like the older Wago style diffs from the early 90s. Which are actually a preferred setup for this kind of application, but those have skyrocketed in price by now. The diffs, the drive shafts, the viscous couplers, all the factory Honda stuff is outrageously expensive. So this is more so the budget way to get that set up with modern Honda parts that you can find anywhere, because CRVs are everywhere and they're breaking down everywhere and they're getting wrecked everywhere, so the parts are available. I mean, I got this entire drivetrain dropout for this car with the engine, transfer case, drive shaft, which I'm not going to reuse the drive shaft, but it did come with the drive shaft and the differential, all for less than $1,000. So yeah, let's break this thing open and I will show you how that works. I'm going to go over the whole viscous coupler setup when I get to a future video when I'm actually setting that up in the car. So yeah, let's break this open. Okay, so now I'm going to be pinning and welding the CRV diff. From the factory, these are dual pump with a clutch pack inside. That's how you get your slippage, since there's no traditional transfer case on a Honda setup. But I'm going to be pinning and welding that because I'm going to be using a Land Rover Freelander viscous coupling and drive shaft for this thing, because it gives you closer to a 50-50 power split. Well, these apparently struggle at anything more than 400 horsepower, and still they only send you like a 40% rear or something like that. So I'd rather just use the proven setup. So it's just all these 8mm bolts, and you're going to have fluid draining. You could drain it first, but it's going to drain anyways if you pop this open. So let me do that and I'll get back to this. Okay. Got the front of the diff part. Broke a bolt, but no big deal. I can weld a nut to it and get it out. But plan ahead, and if you're going to do this, spray some PV Blaster on the backs of all these holes, because those are the ones that get stuck where they corrode and get stuck in the aluminum housing. So give it some time to soak with some penetrating oil so you don't end up like me having to do more work. Or of course, try to torch them if you can, but I'd say just let it sit overnight with some oil on it. So, these are what I have to deal with. I need to get this pinion nut off the front and get the yoke off. But then, this whole basket is what's going to get some pins, get some holes drilled and some pins shoved through and then welded up. So all that will be a solid piece then. Then I believe this is the dual pump unit. I have to look that up real quick and be sure, but I think I could just leave that out completely and get rid of that weight. So yeah, more fun. And really quick, the pinion nut has this folded over edge on it to keep it from backing out. Just grab a chisel and smack it with a hammer a few times to knock that back, as it'll give your impact a lot easier. Okay, so now I have to degrease this drum basket a little bit. Reassemble all this. Again, hard to do with one hand, but reassemble all this. Tack weld the outer ring on the cage. Then once it's all tacked, I could go and drill. I'll probably do 4 holes and 4 pins and then weld it all up. Then weld the pins to the cage. So I will show you what that's like after it's done. I'm going to, once I tack weld it, I'm going to throw this whole thing in my parts washer just to get rid of any grease on the inside, because chances are it'll run out and get into my welds when I actually go to fully weld this basket. Okay, and now with the clutch basket, I have it in the drill press, well, in this case a mill. But I'm just going to drill probably 3 holes, and then shove one of these bolts through, cut the head off, and weld it on both sides and grind it smooth. And then all these clutch plates will be locked together. Okay, first hole is drilled. You got to use a lot of oil with this, because the clutch material is pretty abrasive and you're going to kill bits if you don't. And honestly, this would suck with a hand drill. Yeah, first hole is drilled. So I'm going to drop one of my bolts through, and then drill the other 2. But first hole, the first bolt will keep the plates from moving around, so I don't screw that up. Okay, I have 2 holes drilled. Throw another bolt in. Somewhere like that. No, it's hitting the bottom. 2 holes drilled. If you don't have a drill press, you should probably just buy the lockout plates that they make for these things. But I'm cheap, and this way works too. But they do make plates so that you don't have to do all this cutting and drilling and welding that accomplishes the same thing. I started cutting down my bolts to make my pins. So these, oh, that shot right through the bag. Whoops. So these will go right in there and get welded on both sides. Okay, drum is all welded, pins are all welded, and it's still leaking out and sizzling crap from drilling and material from the clutches. But that's fine, it's self-cooling. So, clean that up a little bit and it'll be ready to go back in the diff. Okay, back to the diff. There's 3 8mm bolts, and then this factory pump comes right off. I'm not going to put it back in because I don't know, weight savings, and apparently it doesn't actually offer any support for the shaft here. So I'm just going to keep it out now that I have the locked clutch basket. So just strip out anything that has to do with the pump, like this filter screen. I'll leave that magnet. There's a magnet that picks up any metal that gets in the fluid. And instead of running the basically ATF that you have to run in these from the factory because of the pump system, you could run traditional gear lube, which offers a little better protection and, you know, viscosity. So let me take this whole thing to the bench now, and I have to weld a nut onto that broken bolt and that broken bolt and extract those. The diff is back together, welded and pinned. It definitely spins a lot easier without having to spin the dual pump. And yeah, I'm just gonna degrease this thing and spray paint it because it looks like it came out of a 200,000 mile CRV.